afternoon. And silence. So, hello everyone. I'm very happy to finally be in person at a talk, at a conference. It's a very nice change, and I'm very happy to be here in Cluj. Actually, it's my first time in the city, and I was quite impressed. I really liked it. So, let's start a little bit about me first. My name is Gabriel Bornea. I'm a team lead at ING Hubs Romania. I usually spend my time in the JVM world, especially Kotlin, some Java, and sometimes I also go to Scala and F# and TypeScript. I'm a big fan of functional programming, and I do functional programming mostly whenever I can on every project that I can do that. However, I do not consider myself a functional programming expert. And I am also the organizer of Kotlin user group Bucharest. About me. Okay, about this talk. So this is going to be a practical approach to functional programming based on the experience that my team and I gained over time on production projects, especially with Kotlin and Arrow. Arrow is a library that brings many goodies from the FP world to Kotlin by leveraging the power of coroutines. What we're going to see is how creating our domain as accurately as possible is going to help us. We're also going to see that we don't really need to use mocks. And we're going to stay away from exceptions as much as possible, and we're also going to stay away from any framework magic. Regarding exceptions, I read a tweet this morning, and I want to read it to you too, regarding exceptions. It's by Louis Cad, and he's GDE, a Google developer expert. And he said, you know these moments when you have a crash, but the stack trace doesn't show where the exception has been thrown from? Happens easily with coroutines or async programming, as the exception is instantiated on another thread. So this is one of the, I don't know, a big selling point for not using exceptions in asynchronous code, because it may not survive asynchronous boundaries. Functional programming is based on a very simple idea, the idea that you can write applications by using only pure functions and immutable values. And pure functions are important because they have some characteristics that are very helpful in our day-to-day job. One of them would be that the output of a pure function depends only on its input parameters and whatever internal algorithm it might have. It has no side effects, and this is very important because a side effect could be like reading or writing to a database, the user input, I don't know, reading and writing from a file, and this is something that we do every day. And yeah, you might think that this is kind of a contradiction between functional programming and what you're actually doing each day. But you'll see that we can write pure functions with I/O operation, and yeah, it's fine, it works. And another thing is that if a pure function is called with the same input parameter an infinite number of times, it will always return the same result, which means that pure functions are deterministic and they're referentially transparent, which again is something really important because you can at any point replace a function with its evaluated value and your program will still work without a problem. So what we are going to do today, basically we have a use case that might seem simple. We're going to register a user, and we are going to get from as input from the user, the username, the email, and the password, and we're going to return the user ID. However, there are some things that we need to think about when we are designing the API. First of all, it's the validation. So we are going to have some business rules that we'll have to enforce somehow and guard our system from invalid data. Another thing that is very important, and maybe sometime we don't put that much attention into it, is error accumulation. So imagine your user registers and he has everything, all of its input wrong. And we return, hey, your username is invalid. He fixes that and he submits again. And then we say, hey, your email is invalid, and so on. So we want to accumulate all of these errors and send them to the user all at once. Another step that we are going to take is going to encode the password. We don't want to save it in plain text. And once everything is successful, we are going to insert the user inside the database. So I don't know how many of you agree with this statement, but based on our experience over time, we found out that accurate domain and domain types, and here I'm not talking about primitives, about strings, ints, and so on, I'm talking about proper domain types, help a lot with bug detection, help a lot with stuff like this that you normally handle during runtime. And what we are trying to do is to pass as much of the responsibility as we can to the compiler. And thankfully, Kotlin has a very smart compiler and can help us in many ways. So let's model our first domain type, which is a user. And as we see, the user is made from the username, email, and password, and also the ID, which is generated when we are inserting it. These are called product types or records. They're also present in Java in newer versions. And they're called product types because they model end relationships. So when you see something that is modeled as ID and username and email and password, these are product types or records. Now that we have our user, let's register. We know that we register a user because, it was in the specification. And we know that it returns an ID because, again, it was in the specification. But if you look at this function and you didn't read the specification, you probably wouldn't know what's happening here. So maybe we should rename it as register user and return ID to be a little bit more clear. And what we're doing here, we are choosing naming convention over type safety. And probably all of us were guilty of this at some point or another. Now, if we invoke this function, we're going to see that we have a problem here. So the first one is that we passed the username to the instead of the email address and vice versa. And by doing this, we end up with corrupt data, with invalid data in our domain. And moreover, the compiler cannot help us because the compiler has no idea what a username is. The compiler knows that, okay, I need 3 strings. I have no idea how to differentiate between your types. And it's a valid thing. Now, since we're using Kotlin, we can use named parameters, and it's going to be a bit more clear for the person that is, for the client of the function, for the programmer that is invoking this function. However, for the compiler, it's the same issue. You're passing invalid domain data. And again, the compiler has no idea that this is wrong. So we can use something from Kotlin, which are called value classes. And value classes were specifically designed for things like this to help us wrap primitive types inside domain types. And this is very good because it doesn't bring any additional overhead. And it's also erased at runtime. So at runtime, you won't have usernames and emails and so on. You have strings, but that's after the compilation, after the compiler made sure that you're not passing their invalid types. Now, if we are going back to our function, we're going to see that we can drop the end return ID because now it's clear from the function signature that it's returning a user ID. It's no longer returning a string. It's returning a proper type, which is user ID. However, if I'm invoking it, I'm going to have some problems again. This is an email, and this is a username. So it's still invalid data. I mean, the compiler can help me, but I'm still going to have to do some kind of runtime validation to make sure that my system has correct information. And to do that, we can use another feature from the Kotlin programming language, which is inside our value class, we can use an initializer block or an init block. And the require is part of the Kotlin standard library. It's a function part of the Kotlin standard library, and inside it we can set our conditions for what a valid username would be. And if it's not, we give back a message, invalid username value. But when we are invoking the constructor of our type, we have a problem. Require throws an illegal argument exception. And imagine, okay, let's forget the fact that we don't want to throw exception, but we have a problem since we have username, email, and password. If all of them throws illegal argument exception, I don't even know how would I know what failed. It's going to be very difficult. So again, we're going to avoid throwing exceptions because we want no side effects. And we also want to accumulate multiple errors. There is something that we can use in order to fix these things. So instead of using an initializer block, we can use a companion object. And instead of using the require function, we can use the operator invoke and make the default constructor private. When we use the invoke operator, from the client's perspective, there will be no difference. For him, it would look like it's still calling the constructor of the type, so there is no difference there from the caller side. But from our side, it's better because we managed to lose the exceptions. However, we're not throwing exceptions anymore, but we still have the problem of accumulating multiple errors. And now we've traded our illegal argument exception over nulls. So yeah, it's not helpful at all. And this is where the first data type from Arrow comes to help us. And this is validated. Validated is made of error type, or it's made of the actual type, the return type. And we're going to clarify this a bit in the next slides. And now in our companion object, instead of using the invoke operator, we're going to create a function from that. It's going to return a validated of invalid username failure. It's a proper type, and or the username. However, this is not enough, because in this case, we are returning a domain error specific for this use case, for the use case of the username. But we said that we want to accumulate errors, and in order to accumulate errors, we need some kind of a collection where we can put those errors. So instead of using invalid username failure, we're going to use something called non-empty list, and this non-empty list is going to take failure as a type. So what does this mean? Basically, a non-empty list, as the name says, it's a list that is guaranteed to have at least one value. So it's never empty. And why is that? Because an empty list of errors is useless. So we can use nulls or whatever. So it's not helpful at all. And what is failure? Failure is basically a type that we defined as a seal type or ADT, where we can specify all of our individual domain errors for each case in particular. These are called sum types, and they model our relationships. So here the failure cannot be at the same time invalid username, invalid email, invalid password, and so on. And this is valid for the validated type as well. The validated can only be invalid, which is the left side or the error, or can be valid the right side. Instead of writing all of this code, over and over again, we can use a type alias, validated null. It's present in the Arrow library, so we don't have to create it ourselves. And instead of writing our return type like this, which is quite long, we can use a validated null of failure or username. Here, if you have one single top failure, domain failure, you could write your type alias even to shrink it even more, I don't know, to something like my specific validated whatever, just of the type on the right side, because on the left side we'll always have the type failure. Now that we've done this, we're gonna need to somehow lift our types inside validated, and there are extension functions in Arrow for that. For the valid part, it's just .valid, and it will return a valid of username. And for invalid, we're going to use invalid null because we want to turn it into a non-empty list. And right now, if we look at this snippet, what it will return is going to be a validated null of failure or username. Now, we've written our domain validation. And what happens here that instead of getting back the actual type, basically we're getting back a box for the username, for the email, and for the password as well. And each of these boxes are of type validated null of E and A, E being the failure and A being username, email, and password. And what we want to do, in case we have one or multiple failures, we want to take all of those failures and put them in the same bag because we want to give them to the user at the same time. And this bag, as you might have guessed, it's a non-empty list of failure or its type alias null of failure, which is basically the same thing. So now we're going to use Arrow as well even further to do the validation and bring all of these errors together if the case arises. And we are going to use the function zip. Zip is a function from validated that can combine itself with other types validated. And now what we are getting here, it's going to be a validated null of failure or of user. But we see something here that is necessary in order to combine things, and that is called a semigroup. In this presentation, I'm going to stay as much as possible away from any complicated mathematical terms, just for this case, where I think it's important for you to see that the idea of a semigroup is not something that you should be afraid of. I'm going to have some basic math that we're going to look over to better understand what a semigroup means. So this is a very simple expression, but it's important how we look at it. So we're going to read it as I have something of some type, int in my case, and I have another something that is of the same type, int. But I also have an operator between those two types, which is the combine operator. Also, combining those two values will produce another value of the same type. Pretty basic. Another thing I want you to take a look at is this other very simple mathematical expression, where we can see that if we change the parentheses in this particular case, it will not change the result. This is called associativity, and is quite important in the case of a semigroup. So basically, a semigroup is just a structure that contains a set, in this case, the ints, and it also has some combine operation that has to be associative. If we were to define something like this in Kotlin, it would be something simple, like an interface that has one function that combines two elements of the same type and produces another element of the same type. For our int, if we were to create an actual implementation of a semigroup for an int, it's going to look like this, where the combine is basically the plus operation, the plus operator. For non-empty lists, even though this might look a bit fuzzy or, I don't know, a bit more complicated. It's actually not, because the only thing that happens here is list concatenation. So in our case, where we're using non-empty lists, we want to concatenate those lists to produce one single list with all the elements inside it. Another thing that we can do, this is not part of Arrow, this is an extension function that we are using because we, for validation, we use a lot of validated nel. And in order to hide the usage of semigroup at each zip, we've created an extension function, zip many, that is doing exactly that. And you can override this for as many validated nel as you need. And now if we are going to use the extension function that we've already created, it looks very simple. We are calling on validated, the extension function zip many, and inside we are creating the username, the email, and the password from the user input. In this case, all of them are wrong. They do not respect our business rules. And what we are going to get back is going to be an invalid, so the left, and inside of the invalid, we are going to get a non-empty list that contains the invalid username, invalid email, and so on. And this would be the first step to validate that the user input is valid. But we have another thing we have to think about. Since we are storing these users inside of the database, we might want to check if those are already present. Without relying on exceptions being thrown from the database for unique indexes or stuff like this. So what we could do here, we could build a function, create a function exists that takes the username as an argument and returns a nullable username, null if it doesn't exist, and the username if it exists. However, the first problem we see here is that we are going to need some kind of database client to be able to connect to the database and execute those queries. And we can pass it as an argument, but that's not very nice because if I have to pass the database client to every function that goes to the database, it's going to look pretty strange. So what we can do instead, of course, there are other techniques that I'm not going to go into them today, like currying and partial application and so on. But what we can do is create a class. I think everyone can relate to this one, where we can pass the DB client as an argument to the class constructor and partially apply that DB client to all the functions inside our class. However, I personally don't like this for several reasons. One of them is that the database client or the, I don't know, whatever template from Spring we're using or from other framework, this can do a lot of things. So instead of my function checking if a username exists, it could potentially do something more, because it can. So I don't really like it. Another thing is that we want to avoid framework magic. I know that this is a very unpopular opinion, but I don't like annotations and I don't like magic. So if I look at this, at least for me, it immediately screams Spring Framework and auto-wired and so on. And I want to avoid this. Another thing here is that we said that we want no side effects. And reading and writing from a database, as we said in the beginning, it's called a side effect, and we want to avoid them. So first we're going to do the hard part, and then we're going to move to the easy part. What we can do here, we can define our exists function as an extension function over a generic type. Why the hell would I want to do that? Because I can do things like this. I can use the where keyword, and I can tell the compiler, hey, look, my generic type R can be of this type, query user by username. But if you're using Kotlin, you're probably thinking, but why don't you create that extension function directly over the type you define there? And yeah, it's a valid question. You could do that. However, if you need a logger, you cannot do that. You cannot create an extension function over multiple types. But with this technique, you could pass as many dependencies as you want to a function. And query user by username is a functional interface or a single abstract method that we are going to use for multiple reasons, but we're going to see in a bit. What you might notice here is that instead of the validated, we are returning something called either. And the difference between either and validated, even though both of them are sum types, either short circuits a computation. And this is what we want, because this type, this single abstract method, is going to be called from multiple places. And we want to accumulate errors probably only when we're doing some validation on user input or some data we get from other systems. But normally, we want to short circuit the computation. We don't want to accumulate. So for this, we are using either as a return type. Of course, we're going to need to make our function return a validated null, because we're checking the email and we're checking the username as well. And we want to do them together, not in 2 steps. But again, we said no side effects. And in order to avoid side effects, we can use something that you've seen in the previous presentation, is the keyword suspend. And we're going to add suspend to our functions. But why? Well, first of all, our first goal is to write side-effecting programs in a safe and referentially transparent manner. We also want, which is, I think, a point that is more important than the other one, is to return exceptions safely. And we want to recover from exceptions at any point. We don't want exceptions to fly everywhere inside the code, and if somebody catches them, good luck. If not, again, good luck. Okay, to better understand this, I've created a simple example where we have a function grid that takes in a nullable string as an argument. It checks if that name is null or empty. If it is, it will throw an exception. Otherwise, it will print, hello, what's your name? And if we run this, we are going to get immediately an illegal argument exception saying that name cannot be null or empty. There is no chance for us to safely control how we are going to handle this potential failure. But by adding the suspend keyword, I'm going to use a low-level API that you are probably never going to have to use in your day-to-day work, but this is just to prove a point, to show you how suspend and suspendable functions can help us. So instead of calling it directly, we're going to use the API create coroutine that takes 2 arguments. The first one is the argument that we are passing to the grid function, and the second one is a continuation that takes another 2 arguments, some context, and the function. Now, if we execute this, instead of getting an exception or a failure or something like this, we're just going to get back a description of our computation, which in this case is called a safe continuation. So we're not getting the exception. The code has not been run. If we want to execute this code, we can use resume on the continuation we created. And the good thing is, so remember, create coroutine had this first argument null, so it should throw an exception. But it doesn't. It returns a failure, and why it returns a failure is because instead of ending up in an exception thrown someplace, it's going to end up in a result. Result is part of the Kotlin standard library. It has a success and a failure type. And this is basically a result. It's not an exception or it's not the actual value, it's a result. And on result type, I can do different things like, I don't know, fold, check if it's successful or stuff like this. So I can control what happens afterwards. But what's a coroutine? Bear in mind that this is a very simplified definition because it's a very complicated subject that takes a lot of time. So this is going to be just a brief explanation on what a coroutine and a continuation is. So basically, a coroutine is a suspendable function, a compiled suspendable function, but that is tied to a continuation. So if we look at our previous example, but simplified without anything else, just to make it easier to understand, what happens is that the compiler, when it sees the suspend keyword, transforms our function into a callback style. So basically, continuation, you can think of continuation as callbacks for our function. And what happens is that inside the continuation, we decide how the program continues. If you remember, the second argument of our continuation invocation was print line. That's exactly what was happening there. That was how I was deciding to continue the execution. I could have done, of course, something else, but just to make it simple, I was just printing. In more technical or programming terms, this is called CPS, or continuation passing style, which, as I've said, is a style of programming in which a continuation decides how the program continues, so a callback. Think of it as callbacks. Now that we've went through all of this, let's put everything together, at least for our exists function. The first thing you're going to notice is this query. Query is part of the query user by username. Is basically the single abstract method that we've created previously on our query user by username type. Warn is part of the logging framework that we are using, because if a user exists, maybe we want to log a warning, hey, this is already present inside your database. However, if you remember, our query function was returning an either, but we need a validated. The good news is that we can switch very easily between these types by using Arrow, and Arrow has an extension function called toValidatedNull, which we can apply to an either and get back a validated non-empty list. There's another way in which we can write this code. So we can either use the declarative way of writing it, or we can use the more familiar way, imperative way that we're used to. This is just the style in which we write code. This doesn't change what we are doing. So inside either blocks, we can write code in an imperative way. Now, if you see here, we have a call to a bind function, and what bind function does, it's actually, since query returns an either, is going to take the value from the right side, in case the request was successful, and assign it to a variable that we defined that we can use later inside the code. However, if the bind operation, if the query operation fails, the bind will short-circuit the computation, as I've said earlier, and will not go forward. We are immediately going to get a failure on the left side. Other than that, the code is pretty similar. We're ensuring that the user is null. If it's not null, we're going to return an error, and we're going to get back the username. Now that we've seen this, our register function put together is going to look like this. So first of all, we're validating that the username, email, and password are valid from a business perspective. Then we are validating that they are not present inside our system. If an error occurs here or multiple error occurs here, we're going to accumulate all these errors together and give them back to the user. Then we're going to encode the password. The encode function, as you might have guessed, comes from the password encoder. And then we are going to store the user, and the store function returns an either, so we need to put it into a validated non-empty list in order to satisfy the return type that we have for this function. And the store function will return the user ID that we have in the return type in the top. Let's talk a little bit about the dependencies now. So we've seen that we can create an extension function over some generic type, and we can use where to tell the compiler what are the bounds of that generic type. But how do we create something concrete that we can use in order to invoke this function? And we're going to use another Kotlin feature, Kotlin language feature, which is called delegation. You can identify that by the by keyword. And what we are doing here, for each of our types, we are basically storing them internally in our registration context class. But that's it, because the compiler will take care of everything else, which means we'll generate all of the methods that are part of the types that we are storing internally inside the registration context, which is cool because we're going to see immediately how this helps. So we said no mocks. Personally, again, unpopular opinion, I don't like mocks. This is free spec. This free spec comes from a testing framework called Cotest. We're using it extensively in our Kotlin projects because it's, at least in our opinion, it's a much better alternative to JUnit. We are very happy with it. We're using it for 3 or 4 years, and we're very happy with it. But again, this is not a talk about Cotest. This is a talk about functional web APIs. So let's look at our registration context. What I'm doing here, I'm creating a value context by instantiating the constructor that we've seen previously. But what you see here are a bunch of lambdas that are passed as arguments to the constructor. And what this right of null is, it's basically the implementation that we are providing on the spot for the single abstract method that we have defined on the functional interface query user by username. And the first one is going to be the query for the username. The second one is for the email. The third one is for the store. And the last one is the password encoder, which we're basically doing nothing. There we're just returning back the password. Now, another thing you will notice here is a scope function called width. And basically what I'm doing, I'm using the width scope function on the registration context that I've defined previously to bring it into the scope to be able to call my register function. Now I'm calling the register function as if it was a part of the registration context class, even though it's not. This is possible because of delegation and because of the Kotlin compiler that can help us with this thing. And assuming that the username, email, and password are valid values from the business perspective, we should get back an either on the right side with the user ID. Because if you see, the third argument is an either that has on the right side the user ID. Now, going back a little bit on contexts, again, we see this extension function created over this generic type, and we've also seen how to create bounds for that generic type. However, what we've seen over time is that this approach is very difficult to maintain, especially if you have bigger functions that do many things, and sooner or later this is inevitable. And we also have this extension function over that generic type, and let's get rid of it. And Kotlin did a very cool thing. From 1.6.20, they released something called context receivers, and all of this plumbing that we did earlier is no longer necessary because we can use the context keyword, and inside the context keyword I can specify all of the types that are required for this function to be able to work. And if you look at this, you can read it like this. In the context of X, Y, Z, I can invoke this function. And this is the only thing that changes, because we're still going to use delegation, we're still going to use the scope functions to be able to call any functions that are part of our context. However, this is a prototype feature. That's why I didn't start with it. It's not something that it is production ready. But we are considering of switching to it for projects that are non-critical, more toy projects that have not that much importance if something breaks or not, just to be able to properly test this feature. Okay, so moving on to Spring Boot. This is APIs in practice, so we're gonna see how we can use everything that we did previously with two popular JVM frameworks, Spring Boot and Vertex. And I'm gonna start with the most popular one, which is Spring Boot. And again, let's look at the goals. So we want to do it declarative way, without annotations, and without magic. Another thing that we're interested in is returning exceptions safely so that we can handle them in a safe way. Yeah, we said almost no annotations. This is the only annotation that is you're going to see in the slides. And we could even drop this completely. You can write a Spring Boot application without any annotations at all. But to make it a bit more simpler for this talk, I'm gonna keep it. So let's revisit our register function, now that is using context receivers. And we see that we have the first type that we need to bring into context is query user by username. This is obviously going to execute a query to a database. It doesn't matter. So since we are using Spring, we want to take advantage as much as possible of the Spring framework. We don't want to fight it. We want to use it in a smart way. So to execute a query, we're going to need some reactive repository or reactive template to be able to do that. However, there's another potential issue here. A reactive template is going to be a Spring Bean, but our type is not. It's something that we define. So how can we do this? First of all, let's implement our single abstract method query for the case of the username. And we can actually implement it by calling, it looks like a named lambda, query user by username. I know from the signature that it could potentially fail because it returns an either. So we're going to use something either catch. You can see this as a more functional approach to a classic try catch. And we're going to use map left. So the left is the error. In case of an error, we're going to put in our domain type, which in this case is a database failure. However, we need that reactive template. In this case, I'm using the reactive Mongo template to actually execute a query to a database. And I'm using context receivers to bring this template into the context. And then I can use find one, which find one is part of reactive Mongo template. And another thing that I need to do, since I'm in the more Kotlin idiomatic way, more FP way, I'm going to have to call await single or null at the end, because I want to get back a nullable user. I don't want to get back a mono or whatever this function returns. Okay, so I've implemented this. The signature looks like this. Again, reactive Mongo template is a Spring Bean. However, our type is not. And we don't want to use any annotations. But Spring Framework thought about this as well. And they give us a bean definition DSL that will allow us to create Spring Beans without any kind of annotations. And inside the beans block, we can define a named bean in this case. And inside the bean block, we can use our function we can create our function as a Spring Bean. However, remember, we need the scope to bring into context the Mongo template. And this is possible because in Spring, there is a ref function. And this ref function, what it actually does, it will get a reference to that bean by type or by name or by both or whatever. So you can use a ref inside the bean DSL to get a reference to an existing Spring Bean. We're also going to need routes, and for that we're going to use co-router. There are, in Spring Web Flux, there are two DSLs that you can use here. One of them is router, and the other one is co-router. And co-router is useful when you're using suspendable functions. Then we're going to use the Spring DSL to create our bean. And because we are using the co-router, we can call the register, the suspendable function register. However, this returns an either, and the co-router requires a server response because obviously you want to return an HTTP response to your client. So for that, we're going to use the fold function on either. On the left, we treat the errors. On the right, we treat success. Obviously, you might want to do more with your response than just returning it to the user, but to keep it more simple inside this presentation, I'm just returning the value. Probably you don't want to do that. Okay. Now that we've seen how to create beans that go to a database, we're going to also register the registration context as a Spring Bean because we need the user routes to be a Spring Bean as well. And moreover, we need to pass the registration context inside it. And we're going to use ref as well. And since the compiler is quite smart, you could also do it like this, because the compiler knows that user routes is of some specific type. And since the ref function is an inline function, inline functions in Kotlin are basically functions that are copy-pasted wherever they're needed. And that's why you can use things like reified generics that in Java are not possible. Okay, now that we've created our beans, we also need to register them to the application context of Spring. And yeah, it's quite easy. We pass our bean configuration to the add initializers function. And what the add initializers function does is basically applies everything that is inside there to the Spring application context. And we have a fully working Spring application without any changes to our domain. Now, moving on to Vertex. Vertex is not a framework, it's a toolkit. It's more lightweight, I would say. And it's based on the Vertex event bus, which is used to pass asynchronous messages in memory between different Vertex components. However, this is not a talk about Vertex, but how we can use Vertex with our implementation. We still have the same way. We want to do it in a declarative way. We want to avoid any magic. We want to have safety. And a Vertex application, basically, when you look at their website, it would look like this. It's something that is built around the concept of a vertical. And inside that vertical, you have start, stop, and other things that can help you configure your application. What I like to do in my apps when I'm using Vertex is also to add a main function, because it's much easier for me to start that application from the IDE. However, this is not mandatory, and you're probably not going to see it in many Vertex examples or tutorials or so on. Okay, let's implement our query user by username. Just like before, we're wrapping it inside an either catch. We're bringing inside the context a Mongo client, which is basically more or less an equivalent to a Spring template. And inside, just like before, I can use find one, await, and then map it to whatever I want. As you might have guessed, find one comes from Mongo client. However, Vertex doesn't have an advanced DSL for Kotlin like Spring does. So if you see here, the find one, for example, takes 3 arguments. One of them is the name of the collection. The other one is the query as a JSON object. And the third one is the JSON object that Vertex is going to use to populate with our response. So it's a bit more, I don't know, verbose, or I don't know, requires more arguments. But other than that, it's pretty much the same. Again, Vertex doesn't have a DSL to create routes, but since we are using Kotlin, we can create extension functions over the Vertex router, and we can use inside it things like post, pretty similar to Spring. We're bringing the registration context inside the context of this function. We could also pass it as an argument to the function. It's just another way of doing it. And inside it, I can call my register function. However, there's a problem here. When you try to run, when you try to compile this code, you're going to get a compilation error saying that you cannot call a suspension function from an unsuspendable context. And that's going to be a problem because, as I've said, Vertex doesn't have direct support for that. But what we can do, we can create a scope in which we can, a coroutine scope, in which we can execute our suspension functions. And we're going to use the Vertex dispatcher. And we are using Vertex dispatcher because the dispatcher uses under the hood the event loop that I've told you in the beginning. And again, we don't want to fight the framework. We want the framework to help us. Another thing we're going to have to do is to write an extension function over the Vertex root, and that extension function should be able to handle suspendable functions. And as you see here, we're using the Vertex scope, and inside the Vertex scope, we are launching our function. The last thing that we need to do is to create an extension function over the router, the Vertex router, to be able to use the handler that we've defined above. And now that we've done this, instead of using the post that comes from Vertex, we're using the post that we created as an extension function and do pretty much the same things that we've did with our Spring Boot app. Now, if we put everything together, it's a bit more work because Vertex doesn't enforce you a specific way of writing code. Basically, you can do whatever you want with Vertex, but because of that, you have a trade-off. Many things you have to do by yourself. Another thing that is important here is the Mongo client, and this is just a builder function that is going to create a Mongo client that we are using inside our query types. And yeah, that's pretty much it about Vertex as well. Key takeaways, please try to use functions as much as possible because they are much easier to test if they are pure, they are deterministic. If you look at the signature of a function, you should immediately understand what that function does. Your functions should be total and not partial, so I don't know, exceptions thrown or getting back things that you didn't expect. So just by looking at the signature, you should understand what a function does. Try to use the compiler as much as possible. And this is, I think it applies to Java since newer versions, because there are a lot of nice things that came into Java, like records, switch expressions, sealed hierarchies, and so on. Try to think in immutable values, because immutable values make concurrency a lot easier. You don't have the fear that, I don't know, some thread has modified my value and I'm getting back something that I wasn't expecting. And thank you very much. If you have any questions, please go ahead. If not, you can find me around here and ask me anything you want. Thank you.